Welcome to Yantra Technologies. In this present video, we are going to learn how to interface the HCSR04 ultrasonic sensor with the Raspberry Pi and to make it working like a obstacle sensor. So whenever an object is placed in front of it at a distance of less than 25 centimeter, it is going to print the distance and a warning message that an obstacle is detected on the LCD screen. Let us see how it is going to work. In the codes given to you, there in the folder, if you go to ultrasonic, there you will find ultra.py. This is just for printing the distance. It doesn't print any obstacle sense. It doesn't sense any obstacle, just it prints the distance. If at all you open this pi, let me show you this also. So if you open it in Thorny, you're going to see this ultra.py. When you run this, actually the pins are also mentioned here. The trigger pin is GPIO 23 and echo pin is connected to 24. So on this board, it is GPIO 23 which is connected to trigger, GPIO 24 which is connected to echo. So no need to make any connections. If at all you want to choose a different pin, then remove these jumper caps, use the female to female jumper cables and follow this pinout mentioned on this sheet and use any other pin which is freely available. So in this case, you don't have to do any wiring. So the wiring is already done. And this ultrasonic sensor is now running on 3.3 volt. Please remember this. This is not running at 5 volts. It is running on 3.3 volt. Now when you upload the sketch, when you run the sketch, it might throw you a warning, but don't have to consider that warning. You see ultra.py is running. It is giving the warning of GPIO out. Don't worry. See, now it is printing the distance on the on the LCD. See, I'm putting my finger, it is 6 centimeter, 5 centimeter. When I move it, of course, I'm taking video. So I'm waving my hand. So it is printing the distance. So it only prints the distance. It doesn't care whether the obstacle is there or not. This is one code. Whereas there is another code. Let me stop this. And in the same file provided to you in the same folder, you have another sketch called obstacle detection.py. So if you open this, it will open in Thorny IDE. So this is obstacle detection. This code is a little bit modified compared to the previous one. Here we are not only printing the distance, but we are also sensing the distance. If at all it goes less than 25 centimeter is the obstacle limit which we have set. If you want, you can change it to any desired value. And remember, the maximum distance sensed by this sensor is less than 2 meters. The accuracy of the sensor keeps on decreasing. If it is up to 100 or 120 centimeter, it gives you perfect values. Beyond that, any obstacle in the field of view may cause erroneous readings. So better you keep smaller values only. So it prints obstacle detected. Don't get confused. There is no typographic mistake. Actually, the LCD can accommodate only 16 characters. That's why the obstacle LE is removed and it is printed as obstacle detected, and the distance is printed on the second line. So when I run this script, so it is now running and it once again throws the warnings. Don't get confused with that. So you can see the difference. It is now saying obstacle detected because something is, I'm using my camera. So the camera is now at a distance of around 33 centimeter. When I pull it down, you see in the camera the distance is decreasing. Whenever this camera is less than 25 centimeter distant from this, see, it prints obstacle detected and the distance is, see, it's decreasing. Now it has come to 17. Now it is 16. Right, when I'm moving back, it is increasing, and whenever I am above this 25 centimeter, it goes back to the distance, and the last obstacle detected distance will be in the second column. It remains there. Only when you go below this 25, once again it gets updated. Hope you have enjoyed all these videos, and thank you for watching my video. Thank you.